Hey class, going to continue with 7.4. This is page 4, half angle identities. So there they are. There's your list of what you'll be using. If you're curious as to where these come from, they're just derived from the double angle identities. It's kind of a manipulation of those. So I'll show you one. There's the double angle identity for cosine, one of the versions. And really all you do is algebraically solve for cosine theta. Right, so your first step here is adding 1 to both sides. And then you end up with cosine 2 theta plus 1 equals 2 cosine squared. Then divide both sides by 2. So then you have cosine 2 theta plus 1 all over 2 equals cosine squared theta. And then square root both sides. And when you do a square root of both sides, you get a plus or minus. Right. Okay, so I just manipulated the double angle identity. And now notice the angles. So you have this angle here and then a 2 theta there. So notice that this one is just half of that one, right? So I could do a little substitution to get the actual identity. I'm going to let 2 theta equal A, right? Or then theta is equal to A divided by 2, right? So I'll do that one final substitution to make it look like the list. So 2 theta replace with A, and theta replace with A over 2, okay? And then that's that first one right there. Right, and the others are similar. You know, we've got quite a few different variations for tangent. If you're wanting to play around with those, see if you can drive them, go for it. It's kind of fun. And the textbook has them as well. Okay, but we're going to use them. So let's jump right into some problems. The first type are finding some exact values. So let's find the exact value of 112.5. Okay. What you want to first do is try to write 112.5 as something divided by 2, or in other words, double that angle. So this is the same as the cosine of, if I times that by 2, it's 225 degrees divided by 2, right? That's equal to 112.5, okay? And then what that does is identify your A. There's your A that you're going to plug in to the other side of the equation, okay? So now I'm using that very first identity, this one right here. I'm just writing the square root side. Right? So it's plus or minus square root 1 plus cosine 225, that's A, all over 2. Okay. And so one thing you're going to have to do on these is decide, is it plus or minus? I think there's a couple of problems that just have you do that only. And you'll know which one it is based off of which quadrant 112.5 is located. Right, so 112.5 is between 90 and 180, which is in quadrant 2. Right, so that's in Q2. And you know, in quadrant 2, cosine is negative because it's on the left side of the x-axis where values are negative, x values are negative. So you know this one's going to be a negative result. Okay, so I know it's negative, and square root 1 plus. Okay, the next thing I got to figure out is cosine 225. Refer to your unit circle, which maybe you can just see it in your head. Right, 225 is quadrant 3. It's right there in the middle, that 45-degree reference angle. That's going to be a negative root 2 over 2. All over 2. Okay. And that's pretty good. Now it just needs some cleanup, right? So I need to get rid of that complex fraction. I'm going to use my trick. I multiply by the denominator. I don't know what happened to my colors here. They look different now. I don't know, I changed my colors somehow. Anyway, doesn't matter. Let's use this color. What does that look like? Okay. I'm going to multiply top and bottom by 2 because that's going to cancel out that 2 in that denominator right there, right? When I distribute. Okay, so this is going to be negative square root. When I distribute that 2, it's going to be 2. I guess a plus, a negative is just a minus, and then root 2 all over 4. 2 times 2, 4 down there. And then the only other thing I can do is take the square root of 4, which is equal to 2. So this is equal to negative square root 2 minus square root 2 all over 2. Lots of 2's. So yeah, you end up with a square root inside a square root, but there's really nothing you can do to simplify that. So just leave it and call it good. Okay, good times. How about tangent to 22.5? Okay, so my first trick, double that to 22.5, which is 45 degrees. All right, so 22.5 is 45 divided by 2. That identifies as my A. And then now I can use really any of the 3 I want. Right, I've got 3 versions of this. Whichever one you think looks fun. This one might be my favorite because the denominator is the simplest, right? And a nice simple denominator probably means less rationalizations or dealing with that, less work, right? So I'm going to try that version, right? So it's 1 minus cosine 45 divided by sine 45, right? Okay, and then now figure those out. Cosine 45 is root 2 over 2, and so is sine root 2 over 2. Okay, and then finally, yeah, we gotta times both these by 2 to get rid of those complex fractions, right? And then maybe a rationalization after that. So let's see, what's that going to end up being? We're going to have, if I distribute that 2, I'm going to have 2 minus root 2 all over root 2. Finally, rationalization. So just multiply the top and the bottom by square root 2. And then we should be done. So if I distribute that root 2, 2 times root 2 is 2 root 2. Root 2 times root 2 is 2. And then root 2 times root 2 on the bottom is just 2. Okay. Ooh, I can take one more step because I have all those 2's, right? So you can reduce those if you want to just cancel them all, or really what you're doing is just taking the 2 out, right? And then canceling those 2's. So this is root 2 minus 1. Final answer. All right. How about these kind? These are a little different. Now you're starting with the right side of the identity, noticing the pattern, and then writing it as the left side. Okay. So this one I have 1 minus cosine over 2. That's the sine. 1 minus square root 1 minus cosine over 2. So I'm going to write this version right there, identifying the A as the angle given. So I need to write this as sine of A divided by 2. So this is sine of 24 divided by 2, which is sine 12, and that's not on the unit circle, so I'm stopping. That's it for those. This one, let's look, 1 minus cosine, 1 plus cosine. There it is, it's the tangent A divided by 2. Okay, so I'm going to write this as tangent 113 divided by 2. And then 113 divided by 2, can I do that in my head? if it's at 56.5. And that's definitely not on the unit circle, so we're going to stop there. Okay. We've got a few more, just these problems that are like the given that's. So I'll just continue on here and knock out this last page. These are similar to the ones we've done before. First start with an identity, cosine of the half angle, cosine t over 2. So let's do A first. Cosine of t over 2 is plus or minus square root 1 plus cosine t all over 2, right? So again, I'm just using that top identity, right? This one, just instead of A, I have t, okay? And then I'll figure out the plus or minus at some point. Okay. Now I know cosine t, that whole thing is 2/5, right? It's not giving me the angle, it's giving me the cosine of the angle, 2/5. So I replace that whole thing with 2/5. 1 plus 2/5 divided by 2. All right, and then now it's just about cleaning this up. Okay, so multiply my funky colors here, multiply by 2. And we're going to get, by distribute, plus or minus square root. Hey, sorry, not 2. What am I talking about? The denominator is 5. You're probably like, oh, he's making a mistake. Okay, I caught it. Let's erase those. Should be 5. My bad. There we go. So I'm going to have 5 plus 2 all over 10. Okay. So this is plus or minus square root of 7/10. Rationalize, multiply top and bottom by square root of 10. And we got a final answer here. Plus or minus square root of 70 all over 10. 7 times 10, 70. They're both on the square root, so you just got to multiply them together. Okay, I never decided plus or minus, so I guess I got to do that. The way to do that is notice that t is in quadrant 4. Quadrant 4, so that means that t is between 270 and 360 degrees. Right? So where is t over 2? What if I divide everything by 2? Right? Then that is going to leave me with 135. So t is between 135 and 180, which are quadrant 2 angles. Right? So what do we know about cosine in quadrant 2? Cosine in quadrant 2 is always negative. So this one has to be negative. Right? So this, my final answer is negative root 70 over 10. Okay. How about sine of t over 2? It's similar. I'm just going to have 1 minus, right? Cosine t, which I know is 2/5 all over 2. Right? And then do your times by 5. So everything's the same. It's just you're using minus instead of plus, right? So this one's going to be plus or minus square root of 5 minus 2 all over 10, which is plus or minus square root of 3 over 10, or square root of 30 over 10, plus or minus. And then how about sine? We still know that t is in that quadrant 2, right? So what do we know about sine in quadrant 2? Because this one's a sine. Sine in quadrant 2 is always positive. The y value is positive in quadrant 2. So this one's positive root 30 over 10. Okay. All right, use the identity and some unit circle knowledge, and you should be okay. All right. I got to stop there. I'll just do these last two on one more video. But let me stop for a minute, take a little break, and I'll be back in the next video. Okay, hope all is well. Talk to you later.